Another problem that we're going to want to solve is this type of problem where we have a linear equation. X to the 103 is congruent to 4 mod 11. This is off of page 67. And what we're going to use is we're going to use this idea that x to the 10 is congruent to 1 mod 11. And this is by using Fermat's Littel theorem. And so we have this idea that we can use here, and it allows us to rethink the x to the 103. What that is going to be equal to is the same thing as x to the 10th power raised to the 10th times x to the 3rd. What this is going to tell us is that this is going to be congruent to 1 times x to the 3rd mod 11. Okay, so what we're using is this idea right here that x to the 10th is congruent to 1, and so what we have here is just this x to the 3rd power. So we're really looking at this as x to the 3rd power congruent to 4 mod 11. And so instead of doing 103, we only have to take a look at the 3, and it makes this problem a lot more simpler to deal with. So what we'll do is we'll just take values, and we'll take the values all the way up to 10, starting at 1, and plug them in. And so 1 cubed is going to be equal to 1, which is not going to be congruent to 4 mod 11. So we can take the next value. X is equal to 2. 2 to the 3rd power is equal to 8, and that's not going to be congruent to 4 mod 11. We could continue doing this, but I'm going to go down and pick x to the 5th power, and when I take x to the 5th power, this is going to give me 5 cubed, which is equal to 125. And what we're going to find out is that this is actually congruent to 4 mod 11. What you have is 125 is actually the addition of 121 plus 4, and 11 goes into 121 11 times with your remainder of 4, and so the answer here is that x is equal to 5 is a solution. So that's how we use Fermat's Little theorem to solve these types of equations.